And now we go with the problem 3 of the midterm, a second order circuit. The circuit in the figure has a voltage source on the left with the value V of t, U of negative t times 10 cosine 50t volts. At t equals 0, the current source on the right, this one, is activated. Observe there is a heaviside step there, right? A unit step. A, determine what is the initial voltage in the capacitor with this polarity and what is the initial current in this inductor here. Let's concentrate on that part A. We observe that before t equals 0, the circuit has been like that for a long time. It is in steady state. But the only one source in the circuit before t equals 0, that is the voltage source on the left, is a sinusoidal source, so the circuit is in AC steady state, and we can use phasors to solve for currents and voltages, and that is exactly what I'm going to do. What about the current source on the right? Well, before t equals 0, U of t over here is 0. The value of the current source before 0 is 0. It's an open circuit. That's why it doesn't appear in the circuit before 0. Wow, what is that? Well, this is J omega L, the impedance of the inductor. Who's omega? Over here, 50 radians per second. And this is negative J over omega C. What about the source? Well, the source is going to be represented by a phasor. What type of phasor? Peak value or RMS value? Because I will need the peak value of the results, I will use peak value phasors in this time. You can use RMS value phasors and multiply your results by root 2 at the end too. If that is the current in the inductor, is the value of the source 10 with 0, which is 10, divided by this impedance 3 plus J 12,5 plus the parallel of this capacitor and that resistor. Use your calculator and find what is the value of that phasor. We begin by entering the value of the source, 10 volts, and then the impedance 3 space 12.5, make a complex number of that, and now 5 ohms, enter, and 0 with 0.2 negative, make that a complex number, put them, now they are in parallel, like so, and then in series, and then divide. That is the current in the inductor as a peak value phasor. Let's write that current as a function of time, and then we can evaluate that at t equals 0 to get the initial current in the inductor. The current in the inductor as a function of time has a peak value of 0.79 and an angular frequency of 50 radians per second from the source and a phase shift of negative 76.26 degrees. From that value, it's going to be easy to find what is the initial value IL0 of the current in the inductor. Evaluating that function of time at t equals 0, we get this expression. Evaluating that, and such is the initial value of the current in the inductor. Let's go with the capacitor now. The voltage in the capacitor is going to be the voltage of the source, 10 volts, minus the drop in the impedance, 3 plus J 12.5 ohms. Of course, I compute that as phasors, and then from the peak value phasor, I write directly what is the expression of time for the voltage in the capacitor. And that is the function of time that I will evaluate at t equals 0 to find Vc naught, the initial voltage in the capacitor. And that is the initial voltage in the capacitor. Negative 0.152 volts. That means that it's upside down with respect to the polarity that we chose in the circuit. That completes part A of this exercise.